Okay, this will be unit 10. From unit 10 we covered these parts and we were on the identities section. Remember these triangles, you have to memorize them. Although you'll be having your calculators, but once memorized, many questions would be easy for you to attempt. For example, this question right here, as I have memorized those triangles, so I know I'll draw them for you to compare. These were the two triangles, 90 degrees, 45 each. So this is 1 square root 2 first triangle, and the second triangle was 90 60 30. This is 90, this is 60, this is 30, this is 1 2 and square root 3. Because I've memorized these, so I can see exactly that this is 60, and when 1 is opposite to 30, look at this red triangle, 1 is opposite to 30, so I know this is 2, this is square root 3. Coming on the left hand side of the triangle, if this is 1 and 45, this is 90 degrees, this is again 45, 1 square root 2. So now I actually know that AC is 1 plus square root 3, and ED and all the other angles. Now look at this, if I have this length and this length, angle at A is 45, so this complete angle would be 45, this is 15. So I basically have this angle 15 and 2. Now I can use sine cos tan or anything else to find the missing values. And also I know that it is an isosceles triangle. So this is the benefit if you have memorized it. You can write them directly. Coming on to the identities part, we practiced till here example A and B. Example 9, we also covered this. Now look at these questions. Simplify each of the following expression. Now what exactly simplification would mean, at what level you will write and make a stop. For example, exercise 10C, question 1A. This is 1 minus cos square theta by 2, whatever the angle is. So if you remember, identities were cos square theta plus sine square theta is equals to 1. Now we have 1 minus cos square here, so I can pretty much think that if I make sine square the subject, it will be 1 minus cos square theta. So actually 1 minus cos square is equal to sine square. So I can write sine square, make sure the angle is same, sine square theta. Simplification done, question complete. More examples. This is 5 sine square 3 theta plus 5 cos square 3 theta. B part says 5 sine square 3 theta plus 5 cos square 3 theta. Again, look at the identity. This is basically, when you take out 5 as common, this is sine square 3 theta, whatever the angle is, and cos square 3 theta. Both the angles are same. Basically it is sine square plus cos square, and sine square plus cos square is equal to 1. So we'll write 5 times 1 and the answer is 5. So sine square A minus 1. C part is sine square A minus 1. If we have memorized it, it is very quick to judge. Sine square theta plus cos square theta is equals to 1. To make this form, we can see that we have to bring 1 on left hand side. So if I write sine square theta minus 1 and take cos on the other hand side, this would be minus cos square theta. So just straight away write minus cos square A, keeping the angle same. Getting it? Part C. This was sine square minus 1. Sine square A minus 1. So we knew that it is sine square plus cos square is equals to 1. In order to get this thing, I have to bring 1 on left hand side. So I'll bring this 1 on left hand side and take this cos on right hand side. So when I do that, this is sine square minus 1 is equals to minus cos square. So I can replace sine square theta minus 1 with minus cos square. That's what I did. So this is sine theta divided by tan theta. There were two identities, one of which is this, and the second was tan theta is equals to sine theta divided by cos theta. Now the main question is sine theta divided by tan theta. Because I've memorized it, look at this right here. If you multiply cos with tan and divide tan on the other side, we can directly write that this is cos theta. The terms are interchanged. E part, 1 minus cos square x divided by cos x and square root. One minus cos square x divided by cos x, and the numerator is square root. Now again 1 minus cos square. Main identity was sine square theta plus cos square theta is equals to 1. To make this shape, I have to take cos on the other side. So this is sine square theta is equals to 1 minus cos square theta, right? Now I can pretty much replace this. I can replace this with sine square. So sine square x square root over cos x, first step. Now square root is cancelled out with the square. We are left with sine x over cos x, and we know sine x by cos x is tan x. So this expression right here could be simplified to tan x. Okay, now F part, try this with me. F part is, yes Mohammed? There are only two identities. That's what I'm saying. If you memorized it, that will click in your mind. I'll try to simplify it again. Now look at this question F part. This is 1 minus cos square 3a, right? And I've memorized that cos square theta plus sine square theta is equals to 1, first thing. Now to replace them, I have to make something which would look like this, 1 minus cos square. If I have to make something which looks like this, do I have to take cos on the other side? F part, this is the question, and it is 1 minus cos square 3a. If I have to replace this, I should have something looking like this. Exactly. So this is sine square theta is equals to 1 minus cos square theta. So now I know what I can replace it with. So the numerator 1 minus cos square 3a could be replaced with sine square 3a, numerator. And in denominator, this is cos square 3a, agreed? Now this square goes with the square root, this square goes with this square root, and we are left with sine 3a divided by cos of 3a. So what do we do next? Sine theta by cos theta was tan theta, and we keep the angle same always. Getting the point? Okay, G part. Now this is the first thing. What we do, that is algebraic expression. This is 1 plus a plus b whole square. So this is a square plus 2ab plus b square. With me till now? Expansion of first bracket. Done? Simple algebra, nothing else. A plus b whole square. A square plus 2ab plus b square. Now second bracket. That is a minus b. Yes. No, that's something I also confused it with first time. For cos, it has to be sine square x. That's a whole square, so that is why we are applying algebraic expressions. So now that is a minus b whole square. So that should be a square minus 2ab plus b square. Done? And the third one we copy it down as it is. Now we're getting rid of some fraction, some values which we can. This is positive 2 sin x with this negative 2 sin x. Now simplifying, I can see this number and this number, that is 1 and 1. So I write 1 plus 1 is 2. Then I can see this sine square right here and this sine square here. So that is 2 sine square x. When we are done with all, at the end I see 2 cos square. So I write 2 cos square x. And a little correction. This was plus cos. Let me check it. Yes, plus 2. That was positive. I've recorded negative here. So this is plus 2. So when we take out common, we're left with 1 plus sine square x plus cos square x. Yeah, sine square plus cos square is 1 again. So 2 into 1 plus 1 is 2 into 2, that's 4. Let's try one more. G, this is H. So sine 4 theta plus sine squared theta into cos squared theta. Now whatever we can do to solve or replace, we'll do that. If I just take out common sine square theta, if I just take that out, so I can write sine square theta times sine square theta plus cos square theta. Is it good? Now inside the bracket, that is sine square theta plus cos square theta, and we know that is equal to 1. So this is the final answer. Got it? Okay. Part I, which is sine 4 theta plus 2 sine squared theta times cos squared theta plus cos 4 theta, sine 4 theta plus 2 sine square cos square plus cos 4. Okay. Now you got to have some practice to analyze this question. What I can see from my place is x square plus 2x square y square plus y4. I can see this. Can you see this? Now what I'm trying to imply is this is a squared plus 2ab plus b square. I'm trying to imply this. Easy. A square a practice no, you don't have to substitute them with x, but you have to analyze that this is exactly this quadratic form. A plus b whole square. No, look at this. I'm just changing this shape. Now this is sine square theta whole squared plus 2 sine square theta times cos square theta plus cos square theta whole square. Now can you just compare these two? This is actually a square plus 2ab plus b square. So if it is the case that it is a square plus 2ab plus b square, we can close it down to a plus b whole square, right? Understand this first step, then we'll move on to the second. Mahad, you also clear? Good. So now I'm writing a plus b whole square, and what actually is sine square plus cos square? 1. So by writing this thing, the examiner actually is trying to say 1. Yeah, we can write 1. That that's right, but you won't be able to memorize this. If then yes, you can just state in the exam that I used this identity, hence I'm writing it equal to 1. Yes, you will give the mark. This is what it is, but you will have to state the identity that I'm using this identity and I'm saying that it is equal to 1. Do you remember circles from O levels? We used to write the property that by using this property, or for similarity and congruency, we used to state the property that using this property I'm saying that they are similar. Now there comes the question you will feel a little good about, and by the time you've memorized some as well. Question number 2, it says 2 sine theta is equals to 3 cos of theta, and the demand of question is to find the value of tan theta. Now you know what I was telling you about, that the main questions will have something that convert them into this form. So now we have to do something to convert it into tan theta. And having a look at this sine and cos, we know there are no squares, so tan theta is equals to sine theta over cos theta. It must be something related to this identity. So sine theta divided by tan theta, cos theta is tan, so I'll have to divide this cos on left hand side, so this becomes 2 sine theta divided by cos theta is equals to 3. And I'm bringing this 2 on right hand side and writing sine of theta divided by cos of theta is equals to 3 by 2. Now we know sine theta over cos theta is actually tan theta, so tan theta is 3 by 2. Demand of question was to find tan theta, so your answer is 3 by 2. this all depends on written practice. You keep writing, you keep practicing, you'll be comfortable with these. This is sin x cos y is equals to 3 cos x sin y, and it says express tan x in terms of tan y. Now be careful with the angles, it is x and y mixed. So what was it? Express tan x in terms of tan y. So tan x in terms of tan y, that would mean tan x on left hand side and our answer on right hand side. So if I need x on left hand side, I'm bringing this cos x, dividing it on left hand side, and I'm taking this cos y on right hand side. So sine of x, which was already there, bringing cos x in the denominator, is equals to, we are left with 3 sine y on right hand side and taking cos y on the other side. Now sine x over cos x is tan x, and 3 was there, this sine over cos is tan of y. So this is your final answer. Tan x is 3 times tan y. Yes, this is 211. Okay, now as we are proceeding, look at the questions. It is simplifying itself, it is giving you a target, express in terms of sine only. Now whatever the question is, look at this question number 4, whatever it is, I know that we have to convert it into sine. We should have sine in our answers. So now it is targeted. Now you will know that you have to replace it with what thing. First question is cos square. This will clear your concepts almost by 90%. Now this is cos square. May I directly write 1 minus sine square theta? Is it fine? If not, I can show you. This was sine square x plus cos square x is equals to 1. So what can I replace cos square with? So cos square x could be replaced with 1 minus sine square x. Using this one basic identity, we can interchange them, and I wrote this for A part. Now B part, that is tan square theta. This is the question, and final answer should be in form of sine. Firstly, we know nothing about tan square, but we do know that tan theta is sine theta over cos theta. So if I just write it this way, I can write sine theta over cos theta and whole square. It is allowed in mathematics that you can write this as sine square theta or cos square theta, like this thing. Sine theta whole cube is actually equal to sine cube theta. This is one and the same thing. So we're done with sine square over cos square. We can write directly tan square as sine square over cos square. And next step, numerator stays same. May I change cos square with 1 minus sine square? Now this whole thing is in form of sine theta. It started with tan, it ended at whatever it is, but it is in form of sine. Let's try C part. That is cos theta times tan theta. Question 4C. Cos theta times tan theta. Cos theta stays as it is. Tan was sine theta over cos theta. So cancel out this and your answer is sine theta. Does that make sense? D part. The more we'll write, the more comfortable you'll get. Cos theta divided by tan theta. Now again, because we've memorized it, we know tan is something sine over cos, so we do not change cos and we wait for tan to change it. This is sine theta by cos theta. Now solving this fraction, first I'm writing it this way, it is divided by sine theta by cos theta. If I change it into multiplication sign, this will reciprocate and this becomes cos theta by sine theta. This thing right here depends on your practice. You can write it directly as well. Some students have this practice that they know that this will multiply over here. So now this becomes cos square theta over sine theta. Next step, we know cos square is 1 minus sine square theta over sine theta. Changed. E part. Question 4, part E. This is cos theta minus sine theta times cos theta plus sine theta. Now this is again algebraic expression. You can do it like multiply this cos with both these first and then sine. But I can see that this is a minus b into a plus b, right? So I can directly write a square minus b square. And the examiner requested in the form of sine, so I'm changing this cos square. This is 1 minus sine square theta minus sine square theta. Further simplifying, making it 1 minus 2 sine square theta. Getting it? Okay. Question number 5, one more. Using identities sine square a plus cos square a equals 1 or tan theta equals sine theta by cos theta, where cos is not equal to 0. This will always tell you that it is the denominator is not equal to 0. Prove that. Now this is left hand side equals right hand side. Now this depends on your practice again, that you feel comfortable to start with the left hand side or right hand side. So this is sine theta plus cos theta is identical to 1 plus 2 sine theta cos theta. Now before we start, we don't know we'll be able to show left hand side as right hand side or we should start with right to left. So I'm going with the left first. If I fail, I'll start with the right and see if I can match on left side anywhere at any step. So a plus b, sorry, yes, yes, we can do that, and I'll accept that this was not in my mind. That's right. We can write this cos square plus sine square, that's 1, and this is 2 sine theta cos theta. That's very right. And I'm arranging it again. I'm writing sine square theta plus 2 sine theta cos theta plus cos square theta. So we can see this is a square plus 2ab plus b square, and close it into a plus b whole square. So you've done it, Mohammed. I was trying to go from left hand side. Let me do that so I'll also feel a sense of accomplishment. So this is a plus b whole square, that is a square plus 2ab plus b square, and because you just told us that sine square plus cos square is 1, so this is 1 plus 2 sine theta times cos theta. So left hand side, we started from left and ended at right, or we start from right and end at left. Both are acceptable, and we say left hand side is equals to right hand side shown. So now you're getting it. This clicked in your mind that you can replace this one with cos square and sine square. So that's what I was talking about. Practice. This will click in your mind and it will get even easier. If I compare it with this class, you were listening, and when you'll practice, you'll be writing it. This will be even more easy. Let's try this one more question for today. Question 5b. 1 over cos theta minus cos theta. The more I get careful that I should copy the question correctly, I think, and make a mistake of positive negative. 1 by cos theta minus cos theta is identical to sin theta tan theta. Okay. Now it depends. It's your choice. Again, you may start from either side. If I say sin theta times this is sin theta over cos theta. So sin into sin is sin square theta by cos theta. Now sin square could be written as 1 minus cos square theta over cos theta. Now the actual inspiration is coming from left hand side. I actually know what shape I have to make, so I'm making this decision. 1 over cos theta minus cos square theta over cos theta. So this is 1 over cos theta minus, when you cancel these out, this is cos theta. So left hand side is equal to right hand side shown. Is the idea getting clear? Yes, we can do that. But I'll expect that you practice few questions. That doesn't matter if you come up with the statement that you tried but you failed. That is the success actually. You're trying it. The more you write, I'm sure you'll be able to solve 90% of these questions. Don't jump in this chapter as we used to in the previous ones. You see, I'm doing each and every part step by step. So you can also start with this. This is page number 212. So practice from where we left, and at least try 3 to 4 identities. At least 3 to 4 identities, and you'll be good.